welcome to that session. That one is about Docker. If you're looking for the one about Business Central under the hood, then that's the other one. Also, if you haven't heard about Docker at all, that might be a bit much today, so I give you that chance, and I absolutely don't take that one personally. If you've never heard about Docker, it might be a bit much today. Okay, that's the photographer. So my name is Tobias Fenster. I'm a CTO at Axios Infoma and also a business applications MVP. I tweet a bit and I blog a bit, so if you want to follow what I'm doing, mostly around Business Central and Docker, a bit about TFS, continuous integration, continuous deployment, that stuff, then those are the places where you should find most information. What I have prepared for you today is, first of all, a quick introduction, but that's really 2 slides, 2 minutes into Docker, and then the overall scenario, because I want to make sure that you understand how we are working at Axios Infoma, because the things that I will show you are actually taken out of our daily practice. And depending on how you are organized, for what type of a company you are working, or if you're a freelancer or whatever, that might or might not make sense for you. So I'd like to take a couple of minutes to introduce you to that scenario. And then the 4 scenarios that I've prepared. The first one is a self-service container environment. So the basic idea is that we have a web application, of course, based on Business Central, and that one allows our developers and program managers to just self-service containers. So whenever they need a container on a specific release of our solution or Kronos, they just use that web application and they can get that one. The second topic is multi-container environments. I think you should have seen a lot about Docker in the last 2 days or in the last weeks and months when you've been following what Microsoft is doing, but mainly they are focusing on one container environment. So it mostly is about having one container, doing your development, doing your build, doing whatever you need to do. But of course, if you think further about that one, then it also makes sense to have multi-container environments. Like you have your SQL server and then you have a couple of NAV server containers that are all running in containers. The third topic will be automated extension builds. Now, there have been a lot of sessions around CI/CD and a lot of information in the last couple of weeks, so I will focus on the Docker part and specifically on something that's called a multi-stage image to introduce you to that concept. And the last one is Azure Container Instances. That basically shows you how you can run containers without having to install Docker, just out of the box by using Azure services. And then I was thinking, okay, now this is the last session slot for Tech Days. It's after lunch. How do I make sure not too many of you are falling asleep? And then I also decided maybe it might make sense to let you decide in which order I'll tackle those topics, because they actually are independent. They don't build on top of each other. So yeah, a bit of audience interaction always makes sense. I'm not that guy to tell you need to jump around and hug each other and do that stuff, because I'd be the first to leave the room in that case. So probably most of you are already on your mobile. Why don't you go to that URL and vote for which of those topics you want to tackle first? And I give you a minute to type that one. That's ve.link / and then TD18 for Tech Days 18, and vote, because of course you're going to vote. The hand raising and the clapping didn't work so well in other sessions, so let's see if that one works. And quickly switch over here. It should look something like that on your browser. And then let's see if those votes do come in or not. Actually, there's something that I decided yesterday evening in my hotel room, so I'm kind of scared if that will work or not. Let's see. Yo, okay. We are at more than 130 votes, so that seems to work. On the bottom right, you can see the votes coming in, so okay, I'll leave that one open. You can still go ahead and vote, and I will always get back to that vote when we tackle the next topic, but it seems like self-service is the winner for the first one. Okay, quick introduction to Docker and the overall scenario. What is Docker about? Docker is a software container environment, actually the leading cross-platform one. On Linux there are a couple of others, but as soon as you're starting to look at Windows containers, then Docker really is the only relevant option there. Software container environment means that you have the ability to define something that's called a container, and the base idea of that container is that you put the minimum amount of operating system, of libraries, of dependencies, and your application binaries together into what's called an image, or can think of that as a template, and that defines what you need to run your Docker containers and what you need to run your application. And then when you have that image, that template, then you create from that image a Docker container, and that is the running instance of that image. So you then have your running application. In case of Navision or Business Central, this is actually SQL Server, Business Central itself, and an IIS. The definition is in the Docker file that all of that needs to be installed, and as soon as you run it, those three components, or at least parts of that, will be running inside of your container. In a lot of ways, a container is very similar to a virtual machine, but then in others it actually isn't, and it took me a couple of hours or maybe even days to believe that, so don't try to get an RDP connection inside of your containers, because that just won't work. You really do not have a graphical user interface for your container. Two other things that I'd like to introduce you, because I might mention those in the next couple of minutes. What is a Docker host? The Docker host is the machine where the containers are actually running. So that might be either a physical machine or a virtual machine, it doesn't matter. You install Docker on that one, and then it allows the containers to run. And what is a Docker registry? That's the place where you can push your images, so you can upload them for others to download, and that's called a pull your images. That can either be a public repository. The most widely used is the Docker Hub, and Microsoft is also establishing something that is called the Microsoft Container Registry, mcr.microsoft.com, where we already get the Business Central on-prem images, and I think they are moving all their images over there. So that is the introduction of what Docker is, but then you might still be asking, why do I want to use Docker? And there mainly are three reasons. If you're thinking about developers and operations and DevOps, because that's a buzzword, and I need to hit a couple of buzzwords as well, it's a very easy way to create your deployments, because you can very specifically define what the steps are in that image, in that Docker file that describes the image. So I need to install SQL, I need to install Business Central, I need to install an IIS, I need to install .NET, whatever, and then I need to install my application. So that's a very good way to communicate between development and operations, how you want your application to be deployed. And it also is very stable and reliable, because every developer can do the same, and then you have the same in a test environment, and you have the same in the production environment. And those containers are very isolated from each other. You don't have any interference. You probably have run into cases like it works on the developer machine, but it no longer works on the test environment, because the developer has Visual Studio installed, and then there's a new version of a library, and that is not available on the test environment. Now that's the easy case, but you also have cases where you do run into problems because in your staging environment someone flipped the switch but forgot to flip the same switch on the production environment, so it still worked on the staging environment but no longer works on production. And Docker containers really are a very good way to solve that problem. They also do have a better resource usage than virtual machines, because when you think about it, a virtual machine brings its own operating system inside of that VM, and that takes a bit of an overhead as well. Actually, in case of a Windows server, it's a rather huge overhead for the CPU and memory that is already in use just by starting a virtual machine. And a container is a bit easier on the resources there, because it just reuses whatever the host offers. So it just reuses the kernel of the host. It doesn't bring its own kernel, and that means that you have a lot more resources to play with for your application. And then you have a very big ecosystem. For example, we have SQL Server images, Windows Server images, NAV, Business Central, and then if you look into the Docker world, that really is a huge variety of images that are already pre-built and ready to use for you. So that's it for the quick introduction about Docker. The next step that I want to introduce to you is the scenario where we are working with at Infoma. We are an ISV and we're working for more than 1,200 customers, and all of those are running the same solution. So this is our product that's called Infoma New System. And because of that number of users who are using our product, or the number of customers, we have more than 100 people who are directly working on our solution. That's developers, program managers, back office, hotline support, all those people. So they're really on a daily basis working with our product, trying to improve it, trying to make it better. That means that we have a central team that provides the infrastructure for them. So there are standard images for laptops, central VMs for development, central SQL servers, NSTs, IIS. We try to limit the amount of things that people need to do on their local laptops. And now while we're still working with Seaside and old school NAV, there's a limit to how far you can take that. And of course, there will always be things that need to happen locally, but we really try to standardize that and put things into central environments to make sure that that works as easy as possible. So really, the target for us is to have our technical infrastructure usable as quickly and easily as possible. You need to standardize, you need to minimize friction, you don't want to expect infrastructure knowledge, and you especially don't want to create a need for infrastructure knowledge. Don't get me wrong there, it might make a lot of sense in your scenario to have Docker containers on the local machines for your developers, for your program managers, whatever. But in our case, we have a lot of employees who know a lot about infrastructure, but actually their focus should be working on the product, developing, testing, improving the product. And you have to spend time on setting up your local development environment, then that probably is time that is not well spent because it's not actually improving the customer satisfaction with the product. And with that lengthy introduction, you probably will guess where this will lead to. We have central Docker containers provided by our release management and tooling team. So with that, we are sure that the people who actually are experts in working with Docker and working with Business Central on Docker provide those environments, and we don't have to introduce that knowledge to everyone and fix whatever is happening on a random laptop. A reason for that also is that we can stay away from Docker on Windows 10, which would be the Docker Community Edition, and that one isn't working that well. It will hopefully soon increase a lot, and that might be a point of time where we will look again at if it doesn't make sense to deploy containers on local machines, but currently we stay away from that. And that's also the main reason why we're not using the NAV container helper, because it mostly assumes that you have a local Docker installation, and then there's one of the grumpy old guys who provided a tool to do that on remote hosts as well. But actually, we had professionals in place who already knew how to work with Docker, and the NAV container helper really is a great tool, but it helps you working with Docker, and we had that knowledge already. So again, if you only want to have local containers for development, and you don't have Docker know-how already, please look into the NAV container helper. That makes a ton of sense. And we actually also use it a lot just to see how Freddy has implemented stuff and to see how this or that works. We're just not using it in our environments and just copying the relevant parts for us. So what I'm showing you will be relevant for our scenario. So I guess the technology and the concept should still be interesting for you, but this is the last chance. If you want to leave, now is the moment. And even the grumpy old guy said Docker is interesting, so yeah, might make sense to be here. Okay, so let's check again for the voting. And we have almost 300 votes, and the self-service seems to have won. Okay. So we go with the self-service containers. No, we don't. Yeah, we do. First of all, why are we providing this? Again, that goes back to the things that I've already introduced. We want to have easy access to releases, because we have between 1 and 3 major releases and 4 and 6 bug fix releases for our solution per year, and that multiplies by 2 countries that we're currently supporting, Germany and Austria. You wouldn't think it, but Austrian actually is a vastly different language than German. So we have up to 20 Infoma new system releases per year. And that means that we have a lot of releases already in place where we want to test stuff. And then there's the Business Central NAV things where we have Dynamics NAV, then we have the BC Sandbox, we have BC On-Prem, we even have the BC Sandbox Master, so the upcoming next release. And you might want to check in different scenarios what different things are doing. You might have fixed a bug and you're wondering, does that work with our release in connection with CU16? Why doesn't it work anymore with our release in connection with CU18? Is it a bug that happened between CU16 and CU18, or is it a bug that happens in our code? So you really need to be able to have different environments as quickly and easily as possible to just test stuff and try it out, and then you test it for half an hour and you just throw it away again. So we need to make those releases available for quick and easy tests. And then, as a couple of people already have said in the last 2 days, we of course don't make any mistakes, but in rare circumstances it might still happen. And then you need to create a hotfix on an old release because the customer is not already on the latest release, and then you need to have an old CU, you need to have an old release of our solution, and you need to create a hotfix on that one. So, how does this look like? As I said, this is the front end is built on Business Central. So we have a nice and friendly greeting, and we have a couple of tools implemented in that. And especially we have the container erstellen, which is create a new container. And if I do that, then I get all the containers that we are providing. You can see on top of that here, those are the new system releases. So our releases of the last 2 years, the German ones and the Austrian ones. And we also provide the latest release that we did on the CU that we used. So we delivered our release 18.110 with 2017 CU22, but we might also want to test with the latest release by Microsoft. So we also have a container with 18.111 CU23. So that actually is very easy. It's just one line in a table, and then we're done with that one. As you can see here, we also know which image we want to use, which release we want to use, if we want to use a special database, and what the ID of the release is in case of a new system release. We also have a couple of Cronus containers, and then we have the Business Central sandboxes as well. So now let's create one. As you can see here, it has an end date, and I'll explain in a minute why that is. And now I just kick it off, and that will take a bit, so I switch back here. So what have you seen? There is the front end for the end user, and that is actually just a Business Central extension running on one container host. So of course, that Business Central instance is running inside of a container, and that one has a Business Central extension. Then we have a REST-based API that is running on a different system that is taking the requests. As you've just seen, I've made a request to create a new instance, and that one is accepted by that custom API. That one, in turn, calls a couple of PowerShell scripts, and it also connects directly to the Docker API for other tasks. And all of that is running on a different container host. That's our release container host. So a bit more detail about that one. The Business Central extension is something that we built purely in AL, no.NET additional stuff. The list of available images is just a standard NAV table, or Business Central table in that case. So if you want to support a new image in that tool, we just add a line in that table, and then overnight all the images are getting pulled and downloaded. If that image is already there, it will get overwritten by a new one, so we always are on the latest bits and bytes for those. As I said, the containers are valid for the maximum of 3 days. And the reason for that is that we currently are running this on only one virtual machine, so there's a limit of the resources that we can provide. Hopefully with Windows Server 2019, we will be able to run something that's called a Docker Swarm. So we would then be able to spread that out on multiple containers, and then I would be open to doing this for longer than 3 days. But the fact is that people start using those containers and then just forget to shut them down or delete them afterwards, so they tend to run for a longer time than they actually need it. And with that limit to 3 days, they just get thrown away. The call to the proxy API are done through a REST interface. And as I said, it's to create or delete containers, to get the status, and to get the logs. That REST API is a .NET Core application. What that one does, it first of all creates a group managed service account, and I have a bit more details in the next slides what that actually is, but it's needed for the Windows authentication so that we can log into the container using the Windows credentials. If it is a new system container, then of course we need to restore our database because it contains a Cronus database in the standard image, and we also might need to download our DLLs that are specific for that version from TFS, which is the on-prem version of Azure DevOps that you might have seen in the last couple of days as well. And what that also does then in the end is it constructs and executes a Docker run command. So this does no magic, whatever. It just creates a rather lengthy Docker run command, and that leads to the container being created and started. It also can get the running containers and the logs, and that is done directly to the Docker API, because Docker provides an API, just a REST API that you can talk with. It's a bit complicated to use. That's why we're doing some things in PowerShell, but it's okay. And the last one, of course, is the container itself. We don't do any special custom containers or any special images. Those are just standard NAV Business Central images for Microsoft, but we of course do a couple of scripts in specific settings. The first script we have is one that grants an Active Directory user group access to that machine. So when one of those containers gets created, it looks for our developer group inside of our Active Directory, pulls all the members, and enables them as super users in the database, creates an NAV user, and then we are ready to go. The second script automatically converts the database on startup. We need that because the backup file might have been created with CU whatever 5, and now we're trying to run CU 10 with that one. So directly after startup, it tries to convert the database and make sure that it works with the latest CU. Of course, you can run into problems there as well, but it hasn't happened a lot. We use Windows authentication. We use our own developer license, of course, to get access to our own objects. We enable click once to provide the Windows client, the old one, and the C-side environment, because if you happen to need to create a hotfix for a customer on an old release, then you need that old C-side environment as well, or you might want to test with an old Windows client, and the easiest way to get those is click once, because then you don't want to run into trouble with multiple releases as well. We use something that's called transparent networking. That means that every container gets its own IP address and is rather easily accessible through the standard ports, so you don't need to worry about networking too much there. We have some custom NST and web client settings, and then we set labels to identify the releases. As you might remember in the list, or no, actually you will see it soon, we know who has created that container. To be able to do some restrictions like you can only delete a container if you've created that one or if you're a part of the administrators group. And for that, we need to store who created those, and we, for example, do that through the labels. So just to scare you a bit, this is the Docker run command. And actually, it's not that scary. The first part is just giving it a name and a host name, and of course, it accepts the end-user license agreement because we just have to do that. Then this is the networking stuff where we use the transparent network and we disable SSL usage because we just don't bother internally. We enable click once. And now comes the part that is about the group managed service account and about enabling those developers as users inside of the database. So the security option actually references that group managed service account and tells it to use that to run the container. Then we tell it to use Windows authentication. We create a standard user in case something goes wrong. And then we let it know which domain and which group we want to use, where we pull the users from and enable them. And then we have that script, grant user access zip, that you can see on the very right. And that one is responsible for actually doing all that. So calling AD, who's a member of that group, create them as users and so on. Then this is the second script that we use that invokes the conversion in case we were running on a later CU. And this is the part where we get the backup file from new system, if it's a new system container, and where we also get the DLLs from the TFS server and put them into the container using a volume. And then you can see here we do two custom settings. The first name makes sure that we always directly see if it's a new system container or if it's a standard Cronus container. And the second setting just changes the threshold for the SQL long-running statement logging, because otherwise, when the container didn't get enough enough resources on the host, then it started to flood with messages right from the beginning, and the people using the containers were wondering why they started the container and immediately got warning messages. And this is the last one, just setting the labels. So now I know that I personally have created as an owner that one, and a couple of additional metadata as well. And then we're using 2017 CU16, the German version in that case. So, oh no, not what I thought. Now, how do those group managed service accounts work? I don't want to go into too much technical detail, because that is actually quite well documented and also quite boring if you're not too interested. But to just help you understand what the concept of that is. First of all, you of course need to have an Active Directory, and that Active Directory needs that guy, which in my case is the group managed service account. So that actually is just another type of user, but it's not difficult to create. You just create a new one. It's not a standard user, it's a group managed service account. Then you have your container host, and on that container host you need to install the group managed service account to enable the usage of that group managed service account there. And then you also have your SQL server, if you want to connect to that SQL server using Windows authentication with a database, and on that database, that group managed service account also needs to have access. Then we install a container, or we run a container on that container host, and we tell it to use that group managed service account. What then happens if we make an outgoing connection to the SQL database, it will use that group managed account, and because we have enabled that one before, that will work. So that's just the base idea. You have that special user account, you assign it to a container. The container automatically uses that one to connect somewhere else. The same is true if you try to log into that container, then it will use the group managed service account to connect to your Active Directory and find out if you actually are allowed to log in or not. So it uses that group managed service account for all of the outgoing connections. And with that, I should hopefully have told you enough to see the container up and running. So let's see. There is the TechDays one. And now I can check the log. And I was fortunate enough that it has finished. So what you can see here is just the standard startup of an NAV container. And the special things are happening especially here in additional setup, where we are setting up those development users by first of all importing the Active Directory PowerShell modules, and then we're querying that group that you can see here, and then we're adding all those users and even groups and so on and so on and so on. And in the end we get a link for the web client, for click once, and so on. And of course we also have provided those as links here. So let's go to the click once. Now I can install C-side or install the RTC or whatever I need to work with that environment. I can of course also access the web client, and that might take a minute to start. And let's see. Yeah, but you know how a web client looks like, right? So those additional information that you see here, like the owner, the NAV release, the CU, the build, those are partially coming from the image and partially from those labels that we set, so that we know what the version is, who the owner is, and all that kind of stuff. Okay. I actually wanted to show you a bit there. Give me a second to remove that one. Live PowerShell editing, something you definitely should never do, but here we are. So a couple of additional notes about the group managed service accounts. While we're running on Windows Server 2016, the group managed service account, the container, and the host name of the container need to be the exact same. That is a problem, because every time you want to create a new container, you also need to create a new group managed service account. And of course, you can script that using PowerShell. but it just adds an additional overhead that's not really necessary and doesn't help. And you also can do something like dynamic scaling. Docker offers a couple of mechanisms how you can do dynamic scaling, like I not only want one container, but I want 3 of those. And then it just adds name _1, _2, _3. And again, this breaks the fact that the group managed service account needs to have the exact same name. So that really also is not possible currently with group managed service accounts, but with Windows Server 2019, that no longer matters. The group managed service account, as I said, is used for outgoing connections, especially or not especially, but only then if no other user was explicitly set. So if the standard accounts like local system or network service is set, then the container will just use the group managed service account when it does an outgoing connection. The group managed service accounts also don't have passwords, so you don't need to distribute something there or reset or whatever. They are restricted to the machines. So when you create a group managed service account, you tell it on which machines they can be used, and then they are just available there. And what you need to do is you need to download what is called a credential spec file, and it actually is just a file that knows which group managed service account to use, and then you reference that in the docker run command as a security option, as we've seen before. And if you want to find out more about that one, I actually think that is quite well documented on Microsoft's site there. But if you happen to run into questions, that is a topic where I've spent a lot of time on until I finally got it up and running. So if you start with that, feel free to contact me, and I'd be happy to help. Okay, so let's see where we are with the voting. Do you want to vote again, or should we just take the second one? Let's try again. I'll remove all the votes. No? Just take the topic? Okay. Okay. So let's go with multi-container environments. As a friendly request, I'll of course do that. Multi-container environments, why do we want to use that? There are multiple use cases for this. One of those would be that you have multiple very similar containers that you want to use, and then we have more complex scenarios. The ones where we have very similar containers, for example, are our release tests, because there we just spin up 10 containers for 10 different databases, and they all just need an NST and an IAS to allow the testers to connect to the database. But except for that database and that name, they are all the same. So we need to have a stable and reproducible and easily adjustable way to do that. The second example where we use that mechanism, which is called Docker Compose, is on our tools host, or one of our tools hosts, where we have different images. Like there's an IAS running, there's some other tool running, there are of course also Business Central instances running, and all of those are defined in that Docker Compose file. So this is like infrastructure as code. You just define the infrastructure in that Docker Compose file, and if you happen to throw away the host and create a new one, you just need to move over that compose file, which is stored in your version control. You start all those containers based on the compose file, and you're ready to run again. And the third example that I've prepared for you is our externally available environment, where we have a couple of containers running that third-party developers are using to connect to web services provided in our solution to build their own tools that then connect to our product. And there we have multiple containers, but you don't want to bring them over to the internet without any additional protection. And for that, what we are using is a reverse proxy, and all of those NAV containers and the reverse proxy are all, again, together defined in a compose file. In case you don't know how that works, that is the basic idea of a reverse proxy. So on the very left, you have the client. That one connects over the internet into the reverse proxy. In our case, we're using Nginx, which is a rather popular solution for reverse proxies. And that then just distributes according to the URL to the different containers. So we have 3 containers up and running there for different use cases, and they get the connections. So what actually happens, they of course are defined in one compose file that I will show you in a minute. So what happens if a connection comes in, then that one is directed to our URL and then has in the end of the URL the name of the container that we want to address. That one gets picked up by the reverse proxy, and that one then has a rule that tells it, okay, when that connection request comes in, then I need to route this to the container with the same name. So now the connection is up and running, and they can use the web client, they can use web services, whatever they need to implement their solution. And as I've said already, this is done using Docker Compose. Compose is a tool that is also provided by Docker Incorporated, the company behind Docker. You can just download that one and install it. And what it basically does, it has a descriptive YAML file. YAML is yet another markup language, so that is easy to read, as I'll show you in a minute. And there are all the containers defined, the networking is defined, the configuration for the containers is defined. So you just have one big file where all the information is stored that you need. And in case of the scenario where we have 10 almost identical containers, we have a template in place and then use a PowerShell script to generate those compose files from the templates. So how does that look like? First of all, I want to show you the external one. So what you can see here is the services. So those actually are the containers that are defined inside of the compose file. You can see here that it has a couple of volumes, so file system connections that are brought into the container. It has a couple of ports that is actually listening to the outside. And then it is told to build a new image based on the files that are in that folder. So this is one option inside of the compose file, to provide your own container image, and that gets built as soon as that one starts. But you can also see here the alternative to that is to just provide a standard image that is already available. So in that case, we're running Dynamics NAV 2017 CU5, the German version. And again, we're binding a couple of volumes, so binding folders in the file system into the container. And then you see the, by now maybe familiar environment variables that we need to enter into that one. So we're not using SSL, we're using that database server, you're using that database instance, and so on. And all is, as soon as you get the hang of that, pretty easily readable. You understand what is happening, and it's also easy to change. And this is the configuration for the reverse proxy. That just one knows if someone comes in asking for that specific connection, then it gets routed to that one. If someone comes in and asks for the web service, then I redirect to the same container, but now using the web service port and of course a different URL. So that way we are able to just provide the web client and the SOAP web services to the outside world without actually bringing the containers in a connection to the outside world. The second sample are the tools. Now that one also is kind of familiar. Again, you see that we can have additional tools or additional containers. In that case, that's a Portainer container, which is a tool, a web-based tool to manage containers. Then you can see in that case, we use our own internal registry to spread that image and run that one as well. Here we also have created a static IP address so that we can use our internal DNS servers and our internal SSL certificates to make that safe and secure. And the list goes on here. This is a BC container again, and so on and so on. And you can see here, for example, the gMSA connection as well. And the last scenario for Compose that I wanted to show you is the one where we have 10 identical containers running for tests. So we have a base template that actually contains nothing but the bare stub of the networking configuration and the services. And then every service is built up in the same way. And we have those placeholders marked with those two hashes. So this is the name that we change. This is the image that we use. And then we have the database server, the database instance, and the database name, because they might be different between the containers. And then we just have a PowerShell file that contains all the databases that we want to use in our case. We need to know which release we're currently testing, what database server to use, what database instance, what image. and then that script just goes through those templates and creates a Docker Compose file from those, and it actually also creates the group managed service accounts. The Compose file in the end then looks like this. So now we have one of those services, one of those containers with the name, with the image, the security options, the volumes, and so on. So we just have created a new one, and if we decide to make some configuration setting change that needs to roll out to all of them, we just change the template, run the script again, and we're up and running. Okay, so much for the multi-container environments. Something maybe interesting to note is that you can change that YAML file. So if you only want to change one of the containers and not all, you can just change that portion and tell Docker to update that, and then it will look at the YAML file and find out that the configuration has changed for that one container, and it will remove that one, start it again, and leave the other 9 just up and running as they are. As I've already said, that one allows you to easily update or change your existing host. Just throw the host away, do an update, a new installation, whatever, bring in the Docker Compose file, start it, and you're up and running again. That one would also be dynamically scalable, so you can tell it to use multiple containers for every service. For example, you want to have one SQL server, but 5 NST containers with the same configuration, then that could be done in Docker Compose as well. But again, that's broken because of group managed service accounts in Windows Server 2016. And then if you want to have something more flexible, you can look into Docker Swarm. That allows you to have multiple hosts, multiple virtual machines, which are called nodes. And then you just tell Docker to run a number of containers, and it will find out by itself on which of those hosts it wants to put the container. That will also allow very flexible networking with Windows Server 2019 onward. The reverse proxy will be easier, so yeah, there's really coming a lot of goodness with Windows Server 2019. And then there's something that you might also run into when you're looking into a multi-container environment, which is called Kubernetes. That's the solution by Google to do multi-container orchestration, and there we should get Windows general availability in the next couple of months, and then probably also Windows authentication sooner or later will start to work. Okay. So that's it for the multi-container environments. Now for building extensions using something that's called a multi-stage image. First of all, again, why would you do all of that? Why automated builds? I guess that's you should hopefully heard the answer for that one already. Manually building is not a good idea. It takes very long, and you're sooner or later going to make errors. And you can also, as soon as you have the automatic builds in place, you can do it nightly, you can do it per check-in, you can do it weekly, whatever, but you're sure to quite quickly get the information that something broke in case you made a mistake. Why would you do that in a container? Now, if you think about building and then additionally also doing automated tests, it's very important to always have a clean environment, because otherwise it might happen that you make a change, and that change causes the next build to actually succeed, while it shouldn't have succeeded. Or the next one breaks because there's still some artifact from the last one in there, and it doesn't work anymore. So the best would be to just have a clean environment for every step. And that is what you can very easily do with containers, because just for every build step, for every test, for everything you need to do, you just create a new container, do whatever you need to do, and throw it away again. That brings you clean, controlled, and repeatable environments to do your builds and to do your tests without too much overhead. Now, why don't I use just standard images? The standard NAV BC image is rather large. It's built, as I said, on Windows Server Core, but it adds additionally a size of about 6 gigabytes. And if you want to spread out the builds to whatever Azure Container instances or just some arbitrary host, it always needs to download that image, make sure it extracts that one, everything works, and then it can start that. So with a multi-stage image, we can drastically reduce that size. How does that work? Here. So if you imagine our big Business Central container image, what does that actually all include? We have an IIS for the web client, we have Business Central itself, and we have a SQL server inside of that one. That's the reason why the image is that large. There's just a lot of things that get installed when the container image gets created. And then what we actually only need to build our extension is the compiler and are the symbols that are stored in the database as soon as the NAV server starts. So what we actually want is an image that looks like this. How do we get there? Now if we start again from our standard image, BC Sandbox, that's, as I said, Windows Server Core and 6 GB of additional stuff. Then we do something to get the compiler, a couple of scripts, actually do that to get the compiler and to get the symbols, and that compromises what is called our first stage. So that's the stage where we still have all the binaries in there and the big one. And then we do the multi-stage thing. That means that we tell it, now I want to have a second stage. I want to start from a clean slate, start from Windows Server Core again, and just copy everything over that I need to do the actual build. So now it's a lot smaller. It only contains what I actually need. And if I need to spread that around and run it on a new machine, it gets downloaded a lot quicker. It gets extracted a lot quicker. So in the end, we will have our build container that only contains what is absolutely necessary. Again, how does that work? For that, I show you the source code for that one. No, that's the wrong one. So we have the Docker file here. Try to make that a bit bigger. So as I said, the first stage is just built on top of, in that case, BC Sandbox US as full. We automatically accept the end user license agreement and give it a username and a password. And then we just run the standard start script, but we also have overwritten the crun my in here. So what actually happens is stored here. So as soon as everything is finished, it will create a couple of folders. Those folders will in the end contain the files that we need in the second stage. It will import the test toolkit, just using import nav application object, and it will download the symbols from the server, just making GET requests to the appropriate URLs. So in the end, we will have an application app file, a system app file, and a test app file in our for build stage folder that we then can use to bring it to the second stage. And the AL compiler is stored in the v6 file. That one also is available in the container, and we just copy it over into the for build stage. Now what happens, back to the Docker file. Now what happens in the second stage here, this is from Windows Server Core, so we're starting up from scratch, creating a couple of folders, and then we tell it to use the first stage, but only the C for build stage folder, and put all of that into our build folder. And then in that case, I expand the v6 file to get the actual compiler. I download the sign tool, I download our signing certificate so that I can do application signing after the build has finished. And with that, I have a rather small build image, and we of course use that in automated builds to show you how that looks like. This just uses standard Docker run tasks that are provided by TFS. So it downloads the sources of our extensions, and it then does the actual build by just running our custom build image. So this just runs, it maps the sources, and then with the scripts that we've provided, it just creates the app file. And if it works, then in the end we should have an app file. We also create the test extension the same way. Again, we should have an app file, and then we publish the extension, the test extension, and a couple of test scripts. If it works, then it looks like this. So you can see here the steps that we've just seen: downloading the sources, building the extension. So all this actually does is do a Docker run of our image, and then it calls the build script inside of that image. It does the compilation. As you can see here, now that one has started, it has ended here, and then this is the signing, and in the end we have a signed app file that we then can use for testing. testing, just to quickly show you that one as well, is also done in TFS and also, of course, in a container. Oh, that's the wrong one. So this just runs our tests in one environment, because we currently don't have more environments. And as you can see here, with the limit or with the percentage, not a lot of tests went well in that case. So we now have only 1 working and 6 failures. But of course, there are others where just everything works. Okay. If you want to look more into the continuous integration, continuous deployment, there was a session by AJ, Gunnar, and Camille who talked a lot about that one. The grumpy old guys also talked about that one, so you might want to look into that one as well. And then there was a session by Freddy and Stan Stampin at Directions, which unfortunately wasn't recorded, but you also find the blog post by Freddy that helped there as well. Now what we've seen just now is how we can use a big image and through multi-stage images get that one a lot smaller. Usually it's just the other way around. If you look at something like a C# application, then that needs a full software development kit to build. That's actually bigger. And then you just use the runtime and the build application to bring that one into a target build. So usually it works the other way around, but in our case, we just make a large image smaller. You could also imagine something where the first stage builds your DLLs, so it does a .NET MS build. The second stage builds the app, as we've just seen, and then the third stage might be a Business Central container that just gets your app and gets your DLLs, and then you're up and running again. So with that, we are already at the last topic, Azure Container Instances. What are Azure Container Instances? Now the basic idea there is that you might need to have a number of Business Central installations up and running to test something, to demo something, or maybe for a workshop. And those Azure Container Instances just allow you to run a number of containers without the need to worry about the base infrastructure. So you really just tell it, I now want to have 1 Business Central container up and running, and that's it. You can start them, you can stop them, you can scale up, like now I need 5 of those, you can scale down whatever you need. For example, we did an internal event where we needed 115 of those environments so that people could start to play around with Business Central. And we just used those with a configuration of 4 cores and 12 gigabytes of memory. We started them at 8:30, we stopped them at 1:30. So that meant that we had 5 hours where we just needed almost 500 cores and almost 1.5 terabytes of memory. I guess your local data center would be hard pressed to do that. And it really only took half an hour to start all of those. And it went quite flawlessly. Those containers are paid on demand, so that's the biggest drawback. For all that you get, you of course have to pay for it. But the good thing is that you can very well calculate how much they will be, because there is something called the Azure pricing calculator. So you just select what you want to use. In my case, I want to do a container instance. Then I can add that one. And now I can see, okay, if I want to have 1 container for 1 hour containing 14 gigabytes of memory, 4 CPUs, that would be 64 US cents. That seems quite cheap. Now if you start to calculate that by multiplying with 8 and then multiplying by 20, then you will soon find out that this is nothing that you want to do on a long-term basis. But of course you also pay what you need. So maybe if you're okay with 2 cores and 4 gigabytes of memory, then your hour only costs 27 cents. So really depending on your use case, that might make sense. We only needed 115 of those for half a day, so that made perfect sense. As soon as you get into multiple day usage and you can't really switch them off at night, or you want to keep them running, then you're probably better off using the VMs that Freddy provides, where also everything is taken care of. But then you have the full VM, and if you want to run that long time, you also need to maintain that. So again, depending on your use case, that might be a very valid solution. Now again, what is the base idea? And I try to build up an analogy with local VMs compared to Azure virtual machines. So if you run a local VM, That means you have to have your host machine, you have to have your host operating system, you have to have your hypervisor, Citrix or VMware or Hyper-V or whatever, and then you run your Windows server inside of the virtual machine. So the little box on top should be your virtual machine with the server, SQL, NAV, whatever. Now if you run that one in an Azure virtual machine, that was too quick. In an Azure virtual machine, then all of that gets taken care of for you. You just run the VM and the rest is taken care of by Azure. I think that's a rather familiar use case. So with Azure Container Instances, it's similar. You have your container host machine. You need to worry about the host OS and about Docker, and then you just run your container on top of that one. And with Azure Container Instances, all of that is taken care of for you. You just need to worry about the container running, starting, stopping, maintaining, whatever you want to do there. Now there are multiple ways to get that one up and running. The first one would be the Azure Portal graphical user interface, so just the portal that you use, and I'll show you in a minute how that looks like. Also, you can automate that using the Azure command line or PowerShell commandlets for single containers. You can use templates that are already pre-created, and I'll show you one that does exactly that. So this is just NAV in the Business Central container in the official Quick Start template repository, and then you just click on Deploy to Azure. And then it asks things like which resource group do you want to use, and which location do you want to have the Azure Container Instance, what's the DNS name, and just a couple of inputs that it needs. And in the end, you click on Purchase, you create it, and then you're up and running. The same is true for Azure templates. You, of course, cannot only run them in the way that I've just shown you, but you can also automate that through Azure command line or PowerShell commandlets, and then it works as well. You can also use my Visual Studio Code extension. That one has an action that just creates an Azure Container Instance for you. So if you want to run some development, you only need Visual Studio Code, the AL extension, my extension, and then you kick it off, let it create an Azure Container Instance, and you can start off developing. How does the scripting look like? Now, this is an example that we did exactly like that for the internal event that I just mentioned, and this one would create one Azure Container Instance. So, of course, it needs a name and a resource group to use and a name for the actual container. It uses a template file that in that case I had pre-downloaded, but I also could do a HTTPS whatever URL there. I need to tell it how much memory it wants to use. So in my case, 4 cores and 12 gigabytes of memory. Where do I want to access it? In that case, that's the prefix, and then it should be azurecontainer.io. What NAV release do I want to use? What is the username, the password, and as always, accept the end user license agreement. And then we run that one as job. That means it just went to the background, so we can kick off we could kick off 115 of those deployments and wait until they all had finished, and then we could start them. So, what does it look like when it's done? The problem that leads to a bit longer startup for those is that it needs to download the image again, and as I said, that's a rather big one. Yep. No, that's the wrong one. The image is a rather big one, so downloading and extracting that takes about at least 10 to 15 minutes. Seems to depend on I don't know what, but that means that I can't just create one, because then you have to wait for 15 minutes, and we don't want to do that. So here's a prepared one. That's what it looks like. I have the overview for the container. I can see that I have deployed that one through a template. I can also see, sorry, that's the wrong place. I can also see the container instance in here. So this is how the containers in the Azure portal look like. I get the fully qualified domain name, so this is where I need to connect to, but we see that soon as well. And then I can see that that one contains only one container. The basic idea of Azure Container Instances is that you have a group of containers and you can put multiple of those containers inside of a group. That does already work for Linux containers, not yet for Windows containers, but that should also come soon. And then I have access to the log file of that one, and for whatever reason, you always need to do a refresh once. So this is just the standard startup. And now we get a URL, if I were able to select that one. But I should still have it in my browser history. Yeah. So you can see here, this is Azure container.io. So this is an Azure container instance that we are running. And oops. Of course, I can just log in. And we are up and running. If I need to change something or check something in there, then the container also allows me to do a connection by clicking on connect here. Then I can decide what I want to use. In my case, I want to have a PowerShell connection. Connect that one. And now I have a PowerShell session inside of that Azure container instance. I can import the standard NAV commandlets and do something like get NAV server instance. So you see there's nothing special actually. That's just the same container that you know, the same NAV that you know, or Business Central that you know. It's just running inside of an Azure container. Okay, we've seen that, and we are back at questions and answers, and I'm happy to open that one. So, a second. Thanks for listening. That's the moment where you can leave if you want to. Are those switched on? Oh, really? And then
test.
Ah, yeah, now it works.
I have next scenario. I have a virtual machine in the Azure, and I'm deploying a container with a BC sandbox with a NAV container helper, and I want to have an access outside the virtual machine to the container in the virtual machine. As I know, I need to use ports mapping, and that's all.
You need to do port mapping. You need to make sure that the Azure firewall allows the connection to that one. So you have the firewall inside of the virtual machine. You have the Azure firewall that you need to open up. And the problem is that your container thinks it has some name, but because it is running on Azure, it also has that West Europe Cloud App Azure whatever name. So when starting the container, you need to add that public DNS name. That's an additional parameter in the NAV container helper, or at least at Docker Run you can add that one. So then the container knows that if someone externally calls, it expects that name, and it will answer with the right URLs.
And SSL is not mandatory?
Say it again?
If, SSL is not mandatory. I want to use connection via HTTP.
Yeah. No, you can switch off HTTP if you want that as well.
Okay.
But actually what I would suggest is the standard images that Freddy provides, AKMS, get BC, they are just doing exactly that.
I know, but they are HTTPS.
Yeah, okay. Then all you need to do is take the standard script and do use SSL equals N, and then you don't have SSL.
Thanks a lot.
Okay, you want to? Okay. Other questions?
Thank you. I think you have done an amazing job with these scripts and automating these things. And I would just like to know if you have shared these scripts or parts of them. So
I think I have blogged about everything, and there are at least snippets. There's also some of those are on my GitHub repository, but if you have something specific that you want to have, just shoot me an email, and I either put it on GitHub or send it to you. There, of course, are things that are very dependent on our local infrastructure, so you might not be able to run it directly as it is, but you should be able to just adjust it to your environment if needed.
Of course, and I will start following you.
Okay.
You told today, and we also heard yesterday, that it's not a good idea to use Docker containers on Windows 10.
Yeah.
Can you give like more details? Because we are now trying to use actually this, and
Okay.
we have sometimes problem just like after each 6 weeks we get
Yeah.
an error like your login is from untrusted domain, and we
Yeah.
can't really do anything with it.
Yeah. So that basically is 3 things that cause problems there. The first one is that on Windows 10 you're running the Docker Community Edition. That's the open source version. It always contains the latest bits and bytes, the latest code by Docker, but there sometimes are errors in there. The second problem is that on Windows 10 Docker runs what is called Hyper-V isolation. That means, different to what I told you, on Windows Server it creates a small VM, and that adds a layer around the container to allow it to run, and that also sometimes can cause problems. And the third problem that happens is that you update your Windows 10, that's Windows 10, 1709, 1803, whatever, and the container images are Windows Server 2016, and sometimes you get incompatibilities there as well. So that's why Freddy provided a script that allows you to check the version of your host and create an image that exactly matches your host. So I would suggest to look into the last couple of blog posts by Freddy, so you can use the NAV container helper to create your own image that should be better compatible with your Windows Server Windows 10 version. Okay?
Tobias, thank you. So the question is, during the CI/CD process, you showed that you created container from ls.exe to compile app. Yeah. So what happens if there will be some problems in compilations? You will get just a notification that there are some problems, or you can just export all the problems, for example.
There are actually 2 things. For the compilation, I didn't do that yet, but for the testing, I take the output and just convert it to something that TFS understands, so then you have a better readable. But actually, the problem is that the container will start to run, will stop to run, and it looks fine. So that's why I had one part in there that says check if the up file actually was created. So if a problem during compilation happens, I have the log, and of course the app file won't be generated, so then I know there was an error.
Yeah, actually, just continue this question. When I tried output from ls.exe, it gives only, I think, maximum of 100 errors.
Okay.
So if you, for example, try to convert, CL to AL and try to automate this, so you will not get all the problems.
I guess that is something that the compiler needs to fix. I wouldn't know a way how to do that or how to improve that in a container if the compiler doesn't allow that. Other questions?
Thank you. Do you use a share to share the data when you're changing containers?
You mean a Windows share? Or say it again, please.
Do you use a share to move the data around when you are comparing containers? Or
How do you mean comparing containers?
Yeah, comparing builds, I mean.
Okay. No, I actually just run 2 different containers and connect to those and then compare the results.
Okay.
You spoke about the gMSA. I just wonder if you want to set up the job queue in the Docker. Is that something?
I think there was an issue that with Windows authentication, either the job queue did or didn't work. I'm not sure which of those 2 were, but I thought that was fixed. I know there was a problem, but I have to admit I'm not sure what the status of that one is.
Okay.
Thanks. Other questions? Yeah. I try.
Hi. Are you using the latest Docker builds for your management?
Absolutely. We're pulling them
you haven't run into
nightly.
any compatibility problems?
I mean, it does happen. Our app breaks for the automated build. You use the latest Docker build, and then it just breaks because something has changed. But that just happens. But that actually is the change inside of Navision, and it would happen without a Docker container as well. And
Yeah,
other
no, I mean just the Docker engine itself.
Ah, okay.
I've been struggling with it on a standard 2016. But I have it as a VM, but it's just standard 2016.
Yeah.
And it's been a nightmare to just get Docker to do the basic things.
Okay.
It won't create a network and stuff. And I used the Docker MSFT provider, and it pulled the I think it's 1809 the build, and it's been a nightmare. And so on MSDN I was told no, you should downgrade Docker.
Okay.
To I think it was 1706. So I just wanted to know if you guys.
Yeah, 06 or 09 was the latest before that one. Yeah. We actually haven't upgraded too many of the hosts to 1809. The things that I've seen worked out fine, but a lot of what you've just seen is running on 1709 still.
Because it's so silly, because it's just just running the provider.
Okay.
And it seems to install, but then the Docker service won't.
Okay.
You know, so it's nothing.
Okay. Haven't seen that one, but yeah, I mean it's. The Enterprise Edition should be more stable, but of course it's not bug-free software, so you might run into problems. And 1809 was released like, I would guess 4 weeks ago, so that's...
So downgrading to 1706 might be worthwhile to...
Yeah, that absolutely
try.
might work. I can assure you that everything that you've seen works with 1709. That works, so there's nothing new in what you've seen that only works with 1809.
Okay, thanks.
Okay. Other questions? Someone? Sure.
Can I use port sharing with the different containers?
No. Do you have to map them to different ports? Okay. But as far as I know, you can't share ports with them.
Okay.
Other questions? Nope, that seems to be it. So, thanks a lot for coming, and have a nice day.